Alright, so in this video I'm going to be explaining this important paper with the title MeGraph, Capturing Long-Range Interactions by Alternating Local and Hierarchical Aggregation, a Multi-Scale Graph Hierarchy. So this NeurIPS paper in 2023 has the same spirit as this paper. So graph neural networks, which typically exchange information between local neighbors, often struggle to capture long-range interactions within the graph. Building a graph hierarchy via graph pooling methods is a promising approach to addressing this challenge. However, hierarchical information propagation cannot entirely take over the role of local information aggregation. To balance locality and hierarchy, we integrate the local and hierarchical structures represented by intra and intergraph respectively, a multi-scale graph hierarchy, into a single megagraph. So, the model consists of multiple layers alternating between local and hierarchical information aggregation on the megagraph. Each layer first performs local-aware message passing on the graphs of varied scales via the intra-graph edges, then fuses the information across the entire hierarchy along the bidirectional pathways from the intergraph edges. By repeating this fusion process, local and hierarchical information could intervene and complement each other. To evaluate our model, we established a new graph theory benchmark designed to assess LRI, which is long-range interactions capturability, in which megagraph demonstrate dominant performance. So you see illustration of the graph pooling operation, graph pyramid, and megagraph. Graph pooling is a downsampling process, so comprising select, connect, and reduce steps. It begins by selecting subsets for grouping, and each subset collapses into a new node in the pooled graph. Next, it forms a new edges by merging the original ones, and finally calculates the pooled graph features. In this graph, nodes A, B, C, D, E, F, and G, H, I are pooled into nodes 1, 2, and 3, respectively. While the edges B, E, and C, D are merged into 1, 2. Graph pyramid involves multi-scale graphs derived from iterative graph pooling, with the height indicating different scales. So megagraph is formed by connecting the graph pyramid using intergraph edges. To balance the importance of locality and hierarchy, we amalgamate the local and hierarchical structures of multi-scale graph hierarchy into a single megagraph, as I showed. So let's focus on, so you know that this graph pooling has some functions: select, connect, and reduce. So it's a way to unify different message passing algorithms. And you see here the blue and green circles represent features of intra and intergraphs respectively. And in this figure, the horizontal and vertical directions represent the interaction among the local structure and graph hierarchy respectively. By iteratively applying the pool function, we can collect the intergraphs, and the bipartite intergraph and its features depict the relationships between the graph before and after a pooling process. We introduced the MeGraph and this designed to perform local and hierarchical aggregations over the megagraph alternately. And during encode stage, initial features are inputted into intra-graph GN block, which is followed by a sequence of graph pooling operations to construct the MeGraph and its associated features. In the process stage, the MEE layer, which performs both local and hierarchical information aggregation within the MeGraph, is stacked n times. So what is this MEE layer? It's designed to aggregate local and hierarchical information within the MeGraph. So we consider inputs like this, and we omit the superscript. So the first step applies GN blocks on intra-graph edges, but the second and third steps focuses on multi-scale information fusion. And this cross-update can be implemented via an inter-graph convolution. So this is an illustration of MEE layer, so that you see the blue and green circles represent the features of intra and intergraphs. Gray and golden arrows represent intra and inter-GN blocks. So it has two fundamental modules, the graph pooling operator and the GN block. And they did some experiments on peptide function and peptide struct. And they compared different methods such as graph convolution with their own approach. And also protein data set, NCI1, these are very good for graph classification.